test sequences. Lesson 3. Modifying execution across all sequences. The objective of this lesson is to select and implement an appropriate approach to modifying execution of all test sequences on a test station. Process models affect all test sequences that use them, and test framework architects are responsible for customizing the process model. In this lesson, we look at ways to update a process model to customize error handling, increase the functionality of the process model through the plugins, and implement callbacks that affect all process models run on a station. Customizing a process model. In this section, you'll learn about the structure of a process model and how to customize the process model to implement your custom functionality. You can create a custom process model to be used across all sequences that you want to share similar behavior. The objective of this section is to describe how you can modify a process model to customize operator interactions and error handling across sequences. And the 3 types of process models. This multimedia module reviews the structure of process models and the 3 types of process models that Teststand provides: the sequential model, the parallel model, and the batch model. Refer to the multimedia module in the files provided with this course.
After completing this module, what is the structure of a process model? You will be able to describe the components of a process model and create a new process model. A test system performs a series of operations before and after it executes a test sequence, and that these operations and their flow of execution comprise a process model. Without a process model, you would have to repeat code in each new test sequence. Any changes to the code would also need to be repeated. With a process model, common operations are sourced in a single location, so you need to make changes only once. The process model is one feature of NI Teststand that sets it apart from both commercial and homegrown monolithic test executives. By simply switching the process model, you can use the same test sequence for validation and verification tasks during development and for testing UUTs on the factory floor. Models to the file cabinet. Drag the remaining notes. Drag the default Teststand process models to the file cabinet. Drag the remaining notes to the trash can. Inside the process model. A modular test architecture organizes common test operations inside the process model. These common operations include operator prompts, user interface updates, report generation, and database logging. When you run an entry point, such as test UUTs, you execute a sequence in the process model. The process model interacts with the client sequence files and code modules through callbacks. Most custom process models are based on the built-in Teststand process models. Use the Advanced tab of the Sequence File Properties dialog box to change any sequence file to a process model. By configuring a sequence to be a model type, you give the sequence file more options for calling subsequences than a normal sequence file has. A normal sequence file can include callbacks and subsequences. A process model file can also contain execution entry points and configuration entry points. Here we see the list of sequences for the built-in sequential process model. The icon colors in the Sequences pane differentiate the sequence types in the process model. Next, you will learn more about each type of process model sequence. Sequences that entry points process models can contain normal subsequences that entry points or callbacks can call. Subsequences in a process model are no different than subsequences in a normal sequence file. The client sequence file cannot override normal process model subsequences. When you create a new sequence in a process model, it is a normal subsequence by default. To change the type of a sequence in a process model, select a different type on the Model tab of the Sequence Properties dialog box. There are two types of entry point sequences: execution entry points and configuration entry points. Click on each type of sequence for additional information about that type. A process model can also include callback sequences. There are two kinds of callback sequences that you can include in your process model: process model callbacks and engine callbacks. Here's a summary of what you've learned.
When customizing a process model, NI recommends copying one of the built-in process models and modifying the copy to create a custom process model. The three basic models are the sequential model, the parallel model, and the batch model, which provide a lot of common functionality for test sequences. Some common modifications to these models include creating additional callbacks for client sequence files to override, creating custom execution entry points. When you customize an entry point, include the customization in a callback instead of using a subsequence or inserting steps directly into the entry point, so client sequence files can use a callback to override the customization if necessary. Besides using a process model to standardize tests, a test system should guide the operator through the testing process. Use prompts instead of the user interface to acquire or display critical information. Prompts launch no matter the interface in which the sequence executes. This makes debugging easier because you can effectively run the sequence in the sequence editor. Using prompts means that the test automatically pauses and waits for a response from the operator. So this does not require synchronization with a user interface control. Use test system prompts to tell the operator to enter information, connect a UUT, enter a serial number, power on or off specific functions of the UUT, test types or settings, indicate that a test has returned important information, manually alter the UUT or test equipment, to communicate errors or pass-fail statuses, to connect the UUT to a different instrument, and other operations. However, avoid overusing prompts to display information because users must click each prompt to clear it, which might significantly increase test time. Once you decide to include user prompts, you have to decide if the prompt should reside in the client sequence or the process model. The decision to make is whether the prompt is UUT specific, or does it apply to all UUTs? Examples of prompts that would be UUT specific include UUT connections, dialogues to tell the user to manipulate the UUT in the specific way, and examples of prompts that would apply to all UUTs include a serial number entry, test equipment setup, and error messages communicating pass and fail status. Once you've determined that you need to modify the process model, the next question is how to go about making the modification. If the modification is required for all client sequence files, you can modify a subsequence for functionality that occurs at a specific point in execution during the process model, or add a process model engine callback for functionality that should occur based on events in the client execution, such as executing code after each step or after results are collected. These components of the process model cannot be overridden by client sequence files. If the modification is recommended or optional for client sequence files, create or modify a callback for the process model so developers can override process model callbacks to either disable or change the implementation. Recall that the process model can access additional engine callbacks that apply to steps directly in the current client sequence file. These engine callbacks that affect the current client sequence file have the prefix process model when used in the process model. Process models can also use the sequence file callbacks available to all sequences. The sequence file callbacks when used in the process model apply directly to the steps of the process model itself. To implement custom error handling in your process model, use the process model post-step runtime error engine callback. This callback will execute after an error occurs for a step in the client sequence file or any subsequence call. You can then handle the error yourself in this callback and clear it to avoid the default error dialog. Remember that the error handling should remain UUT agnostic. For example, if you have a custom error dialog that is applicable across multiple UUTs. This slide illustrates how the error engine callback works. The parameters for a callback sequence, shown in the green callback box, indicate the data that will be passed into the callback when it is triggered by another Teststand component. The process model post-step runtime error engine callback executes when a client sequence step generates a runtime error. For this client sequence, the first step does not trigger the callback because it does not generate a runtime error. Neither does the second step. The third step, however, generates a runtime error. This triggers our engine callback. When the error callback executes, the contents of parameters.step are populated with information about the step that generated the error. This information is populated dynamically in order to accommodate any step type information. Exercise 3.1. Customize error handling. In this exercise, you will customize a process model to add a custom error handler for driver errors to provide additional information to test operators. When you have finished this exercise, proceed to the next slide. Remember when modifying the process model to always create a copy of the process model before you begin editing. Where do process models reside on disk? Default process models reside in Teststand, Components, Models, Teststand Models directory, and custom process models reside in the Teststand Public, Components, Models directory. Could the callback have been implemented in one step? Yes, a precondition could have been used instead of the if step. A post expression could have been used instead of a separate statement step. However, this is a lot of functionality in a single step. It is doable, but is much less readable. In the previous section, you learned how to implement a change that affects all sequence files that use a given process model. But what if you want to implement a feature that you want for developers to be able to enable for some sequences and disable for others? In this section, we'll learn about custom plugins and how you can use them to implement changes that your developers can either enable or disable. The objective of this section is to increase the functionality of a process model by implementing a custom plugin. A sequence file called by the process model to extend process model functionality. Developers can enable or disable plugins without modifying the process model. Teststand includes built-in plugins to handle report generation, database logging, and raw result logging. Each plugin contains sequences Teststand calls during process model execution to accomplish results processing tasks such as report generation and database logging tasks. You can create custom process model plugins to extend or modify the functionality of the Teststand process model without changing the Teststand process model files directly. At certain points of execution, the process model contains model plugin sequence calls that call the corresponding sequences in all active plugins. For example, if you enable the report generation and database plugins, the process model calls the corresponding sequence in the report generation plugin and the database plugin once it reaches the model plugin's begin sequence call step. To gain a better understanding of where each plugin entry point is called, inspect the process model execution entry points, single pass, or test UUTs, and note the sequence calls which begin with the text model plugins. In this demonstration, we will review example plugins that Teststand includes to help with the development of custom plugins. You can find these by navigating to the Teststand Public, Examples, Customizing Results Processing directory. This folder contains two main folders with example plugins to help with the development of your custom plugins. The Simple Text Report generates a simplified text report with LabVIEW, CVI, and .NET implementations. The Basic Step Time Report generates a comma-delimited report containing step execution times, and optionally opens the file in a Microsoft Excel workbook. To use these example plugins, open the install sequence for each plugin example, and when it loads, you are prompted to install the plugin. Once installed, you can use the Configure Results Processing dialog box to configure and enable each plugin. In this exercise, you will create a custom plugin to manage the test fixture to set up the active UUT. When you're finished with this exercise, proceed to the next slide. Which plugin subsequences did you keep? The model plugin Configure Standard Options, the model plugin Initialize, and the model plugin Pre-UUT subsequences. What is the purpose of each subsequence? The Configure Standard Options executes when the user selects the Configure button in the Results Processing dialog box and allows the test developer to select between automated and manual modes. The Initialize executes once immediately when execution starts and prompts for all serial numbers to test when the option is in automated mode. The Pre-UUT executes before each UUT test and loads the next UUT. In this section, we'll discuss how to use front-end and test station callbacks to modify how Teststand executes across all process models. The objective of this section is to describe how to use callbacks to implement functionality that executes regardless of which process model a sequence file uses. Front-end callbacks are sequences in the front-end callback sequence file that the user interface can call to share the same implementation for a specific operation that executes when Teststand launches. In this demonstration, we will change the login behavior of Teststand using front-end callbacks. To start, we will copy the front-end callback sequence file to the Teststand public directory. Copy the contents of the Teststand components callbacks front-end directory to the Teststand public components callbacks front-end directory. Once you have copied these files, we will start by opening the front-end callback sequence file to modify the login-logout sequence. Select the login-logout sequence in the Sequences pane and add a message pop-up step to the beginning of this sequence. We will give the message pop-up step a distinct name and configure the message to output. Next, we will want to add a precondition to the step to ensure that it only executes when we launch the Teststand sequence editor. In the Step Settings pane, we will select Properties, Preconditions, and enter the expression !parameters.logout. Parameters.logout is a value passed from the application manager, which determines whether the callback is executing during the login process or the logout process. We will then save our changes and close the sequence editor. Now that the sequence editor is closed, we can reopen it to see our changes. Double-clicking our sequence file again to launch the sequence editor, we will see that a dialog box pops up with what we configured. Overriding a given engine callback has different effects depending on which version of the callback you implement. You can choose to implement callbacks for a standard sequence file, a process model, or for the test station. When choosing the callback to implement, you will need to select the appropriate callback. Each version of the callback can only reside in certain types of sequence files. Sequence file callbacks can be used in any sequence file. Process model callbacks can only reside in sequence files marked as a process model, and station callbacks can only reside in the station callback sequence. Each version of the callback has a different scope. Sequence file callbacks only apply to the steps within the sequence file in which it resides. Process model callbacks only apply to the client sequence file steps. And station callbacks apply to every step for every sequence on a test station except for the station callback sequence file itself. Remember earlier in the lesson when we talked about process model and engine callbacks? Well, you can also implement engine callbacks from the test station so that the callbacks run for every process model that executes on a given test station. In this demonstration, we will implement an engine callback for a test station. Open this Teststand public components, callbacks, station callback sequence file. By default, this sequence file does not include any station callbacks. We will add an engine callback to this sequence. In the sequence pane, right-click and select Sequence File Callbacks. We will select the station post step, click Add, and click OK. Now that we have this callback, we will add a message pop-up to this engine callback sequence. Set the message expression to something along the lines of Step Complete. Once we've configured our step, we will save our changes and go to our mobile device test. We'll select Execute, Run Main Sequence, and click OK in the first dialog. And we will now see that after every step, a Step Complete message pop-up will appear. Open-ended exercise 1. Create a basic process model. In the first open-ended exercise for this course, you will create a simple process model from scratch. Refer to the Appendix A to complete this exercise. In this open-ended exercise, how did you pass the serial number from the pre-test sequence to the post-test callback? One way to pass this data would be to create a serial number parameter for the pre-test sequence. In the pre-test sequence, use a post expression to store the step.result.response for the message pop-up step to the serial number parameter. In the run test execution entry point, set the value of the serial number parameter to locals.serialNumber, and then create a serial number parameter for the post-test callback sequence and set its value to locals.serialNumber. In this lesson, we discussed 4 ways that you can implement code that executes across multiple sequence files. Modify the process model to change execution for all sequence files that use that process model. Create a plugin sequence if you have functionality that can be enabled or disabled for all sequences that execute on a test station. Create front-end callbacks if you have functionality that should execute when Teststand launches. And create test station callbacks if you have functionality that should execute for every process model that runs on a test station.